I've opened the SV Office 5 Manager in this case, and what we have here I wanted to go over is if you download a demo of the software, it comes with over 700 examples that can be downloaded from the cloud by pressing this button. And it will download and install the models on your local machine. If you want to look at 2D or 3D slope stability models, you can come down to these standard projects of Slopes Group 1, which has about 147 models in it. Slopes Group 2 has about 15 models in it, and if you mouse over any of these models, you can see that a thumbnail appears of this model and just examples of, or rather description of the model and the factor safety calculated and run times and details like that are presented in the software. Slopes Group 3 has some other interesting cases that have been created in the software and run. If any model if you want to look at any particular model, you can double click on it and open the model, and it will bring up the particular model you're looking at and display it. Just going back to the manager here, there is another folder that has SARMA non-vertical slice models. It can be used for rock block movement. And then there's shear strength reduction models using SVSLOPE to calculate your factor safety using the finite element method. We didn't talk a lot about that in the presentation. However, the two methods show quite a remarkable agreement in analyzing simple slopes at least. And as well, lastly, there are some that are stress-based and that make use of the dynamic programming search method for analyzing the slip surface, which dynamic programming really offers a much more comprehensive way of determining a potentially non-circular type of slip shape. The dynamic programming method hunts through your stress analysis and finds your most critical slip surface and is not constrained to be circular and therefore has a little more flexibility to determine a more likely slip surface. So a variety of different slope stability models that you can open. If we just go back to a simple model, the software is fairly straightforward to use, and that if you go left to right through the model, it will guide you through the entry of and the building of your model. You can go model settings. You have slip direction, left to right, right to left. Slip shape can be circular, composite, or non-circular. And there's comprehensive searching methods in the software. When we were designing the software, we found that the most common form of variation between different analyses tends to be the searching method rather than the calculation method. Therefore, we put more and directed more energy towards researching searching methods. And you can see if you go to non-circular, circular searching, you get different search methods that are available to you. More recently, we've implemented the cuckoo search, which is shown to work quite well. And we also have dynamic programming, which is a good, robust method for determining your slip shape. And as well, the standard methods, Spencer, Morgenstern, Price, GLE, and as well more newer stress-based methods such as Call-Hallway, and then Duncan three-stage rapid drawdown analysis in here as well. And you can get into advanced topics such as sensitivity probability, spatial variability, or seismic analysis. However, we'll not talk about that today. So geometry, entering geometry can be accomplished very easily. It can be pulled in from DXF files. A variety of different import shapes can be supported. Once you right-click on objects, you can bring up their properties and type in different coordinates or edit them. It's very user-friendly. Then your materials can be entered for the model. If we do a new material, you can see that there's a number of constitutive models that are available for the analysis. Drained, undrained, rock mechanics, anisotropic models, and then unsaturated. So very comprehensive constitutive models. And then there's your specification of how you're searching for your critical slip surface. Here we're using entry and exit method. How you specify your pore water pressures. Here we're using a water table and a piezometric line, and they're drawn. And very straightforward. We can also analyze the groundwater conditions using the SVFlux software and incorporate that. And then there's line loads, distributed loads, and seismic loads that can be applied to the model, and as well as different types of supports, which you can see in this model we have supports installed in the slope to increase the factor of safety. So, and this is all 2D analysis. What we can easily see from, if we click on slopes 3D, that shows our 3D models, and we can see some of our models that are extruded out. We can take any two-dimensional model and just extrude it out with one click of the mouse into a 3D model, and the software rebuilds your model based on the 2D profile in 3D. And you can get a very quick idea for what the 3D model is and handle very reasonable geometry. You can look at this and analyze what the three-dimensional slip shape would be. Here's an ellipsoidal slip shape, and the materials are colored by what material is sheared through at the base of each slice. And then we can also, of course, explode the slice out of the slope to have a better look at it in terms of how it looks. It's a much better idea of that. And then, of course, what's very nice with the software is that it scales up quite nice to more complex type of analyses. You can have very complex topologies, which we found that representation of your topology is very crucial. And here's what we're doing is where it's a typical open pit. We're sweeping a three-dimensional limit equilibrium slope stability analysis around the critical areas to find out where our critical slip surface might be. This is a little more complex analysis, but it's still easy to set up. We're just going to adjust the contours here. And you can see where the most critical slip shape ends up being here in this model. And you get kind of a spatial distribution of your factors of safety. So this concludes our demonstration of the software. Hopefully you've noticed that it is easy to go from 2D to 3D. It's easy to build 3D models using the software, and there's added capabilities and added accuracy benefits in doing a 3D analysis. Thank you again for your time, and please feel free to contact our sales team to be enabled on the software in your particular office.